In this video, we are looking at calculus and the application using calculus. So we're going to start off on the very basics, understanding the power rule. In this video, we are not doing the first principles. So the first principles we are leaving out, and we're just looking at the power rule. So here we're going to start off with rule number 1. So given f of x is equal to 3x to the power 6. So f prime x is equal to 3 times 6. So you might wonder, where does this 6 come from? Where does that 6 come from? Simple. That 6 is the same 6 that was the exponent. So practically what we are saying, take the 6, put it in front of x and multiply. So 3 times 6 will become 18. And then you subtract 1 from the exponent. So look at the question again, right? Take that 6, place it in the front. 6 times 3 is 18, and subtract 1 from the exponent. 6 minus 1 is 5. I hope that makes sense. Looking at the one on the right, same thing, right? So that's the notation. In case it says dy over dx, what does that mean? It means that you are doing derivatives on the x. Okay, so wherever you see x, this is where you're doing a derivative on. Notice here it's the same thing, x. And so this is the same question using 3 different notations. Here dx means you're doing a derivative on the x. You got f of x is equal to 10 x. Notice f prime x is 10. What we are saying, if you have a number with x, all you do is, okay, it's as simple as that. So what they're actually doing there is taking the 1, putting in the front. 10 times 1 is 10. 1 minus 1 will be 0. Okay, and so x to the 0 is 1. 10 times 1 is still 10. So the rule, all you have to do is to remember, if you have 2x, 3x, 5x, 100x, whatever x it is, drop the x, and then your answer will be the number. Right, rule number 3, if it's a constant, then obviously you're going to get a 0 there. So if it's a constant, be it a negative constant or positive constant, doesn't matter, your answer is going to be 0. Right, and then notice that in D's example, you're doing a derivative on x. So because you're doing a derivative on x, and this is a m and not a x, that m is like a constant. Okay, so that m is as good as a number, so that means it will also be 0. I hope that makes sense. So if you're doing a derivative on x and they give you a letter like m, your answer will be 0. If it was f of x is equal to y, but you're doing a derivative on x, that's still going to be 0. And then we get fractions. Fractions is the same thing. All you have to do is write it in another way that makes sense, and that will be a third. Okay, so if you write it as a third x to the power 3, then all you're going to do is place your 3 in front. Okay, so notice here there was a power 3, place the 3 in front. 3 times 1/3 in your calculator will give you 1. So this is why it becomes 1x squared, because we subtracted 1 from the exponent. So a third x cubed, subtract 1 from the exponent, we'll get x squared. Where did the 1/3 go missing? Because 1/3 times 3 will give me 1. And that's how it works. Looking at these examples, notice they look a little more complicated, however, still the same thing. There's a 3 in the numerator. 3 in the numerator means that will be 3 over 1. But because you have a 2 in the denominator, it will now become 3 over 2. So 3 over 2, you can write that differently. So if we write it differently, it will be 3 over 2 x to the minus 4. You might wonder, where did that negative come from, right? That negative is that same 4 over here, but notice that that 4 was in the denominator. So if we move it up to the numerator, it will become minus 4. Remember exponent rules. When we shift between a denominator and a numerator, or from a numerator to a denominator, the sign in front of the exponent will change to the opposite sign. What we are saying, if in the denominator the exponent is positive and you now move that x to the 4 up into a numerator position, this means the sign in front of that 4, okay, in front of that 4 is going to change to the opposite. It was a plus 4, it now becomes minus 4. You might say, but it's still in the denominator. No, it isn't. If you look here on the side, there's no line. There's no line under this. Can you see? X to the minus 4, there is no line there. So obviously it's a numerator. So if there's no line on something, right, then it's a numerator. Notice this here, this line, 3 over 2. That over 2 is only for the 2. This x to the minus 4 is not under that line. Okay, it's not under the line. Therefore, this is now a numerator. So in other words, that can be written as x to the minus 4 over 1. It moved to a numerator. Right, so our method, we said, was first to make it look normal like this. So if you look at this one here, it's now looking normal. And once it's normal, we're then gonna do the derivative on. So now our notation goes from px, which was given, this was the p of x was given. Now we're gonna write p prime x. We're gonna put that number in front. So notice 3 over 2 was there. What number we're going to put in front? Minus 4. Bring minus 4 in front. Minus 4 is now in front. Multiply 3 over 2 times minus 4. Okay? And then you're going to get a negative 6. And then subtract 1 from the original exponents. Notice the original exponent was minus 4. Subtracting minus 1, you're now going to get minus 6x to the minus 5. And then you need to make it look like it's a positive exponent again. So x to the minus 5, push it down to the numerator, the denominator, and now it'll become x to the positive 5. All three questions are the same, it's just the notation is different. Right, going to the next one, we have f prime t. So they're saying derivatives in terms of t. F of t is what is given. So f of t is equal to pi over 2. So we're going to take the 8 and put it in front, and minus 1 from the numerator. Minus 1 from the exponent. Okay, doing that, we have, notice it was t to the 8, and now became t to the 7, because we subtracted 1 from the from the exponent. We subtracted 1 from the exponent. And now we have the 8 in the exponent, which came to the front. There's the 8 there. So now 8 divided by 2 is 4, and that's how we get 4 pi. Right, t to the 7, minusing 1 from the exponent. Right, let's go to the next one, h. If we go to h, notice we have t squared plus x. We're doing a derivative on the x's. Right. So, derivative of x, we said wherever we see x, it will now become 1. Okay, so in effect it was 1x. So then we drop the x. So 1x. And that t squared, notice, is not going to become 2t. No, because we're not doing a derivatives on the t's. We are doing a derivative on the x's. So whatever else you see that's a letter or a number will become 0. 0 plus 1 is 1. I hope that makes sense. Equal to square root of x. Now normally when children see these, they're like, we didn't learn this. Okay, all you have to do is convert those surds into exponent types. Okay, all surds become fraction exponents. Okay, so if you have a square root, it'll become half. If you have cube root, that means power 3. Cube root will become a third. Very, very simple. Okay, so here's a few examples of that. Right, Now all we do, because it's a fraction, we take the fraction, we place it in the front, okay, and then we subtract 1 from the exponent. That will give us negative a half. Now remember, x to the negative half will be a square root, okay, so the square root of x, but because it was a negative, it's going to be in the denominator. Okay, it's very simple. Looking at some of the examples, right? Look at this one. It says f of x is equal to this here, right? It says determine f prime 2. What does that mean? It means do a derivative on that. Okay, so first step, put the 4 in the front, subtract 1 from the exponent. There you have it. Drop the x plus 6. Numbers become 0. Simple. Now you have f prime x is that. Notice the 0 is missing. What you're going to do next? The question said determine f prime 2. This means you're going to substitute 2 into the derived version. So once you got the derivative, right, f prime x, that's the answer. Substitute the 2 into that. Don't take the 2 and put it up here, because that means f of x. You understand? So if it had f without that dash and a 2, this means you're going to substitute the 2 straight here into this one. Okay, but because it's f prime 2, you're going to substitute the 2 into f prime x, which is this one there. After substituting the 2, the answer is 38. Do look at these examples like example 10 before exam. Look at them deeply so that you don't mess it up. Notice that in the exam, this will be, they give 3 examples in calculus. This is your 3rd example, okay, your harder one. So if you can do this one, the other 2 is jam. Okay, now I get the derivative of x. This means we are doing derivatives on all the x's and not the p's. Does it make sense? The p is then like a number. Now you're saying to yourself, shouldn't the p become a 0 because it's a constant? No, because it's attached to x. You understand? It's attached to x in this case. So notice the 2 will go in front, so it'll become 2px. Okay, is it good? So putting the 2 in the front, it'll become 2px. Correct, 2px, right? Notice here you have p squared. Now many children will put that 2 in front of p and think they got it right. No, you're doing a derivatives on the x's. Here we weren't doing a derivative on p, we put the 2 in the front of the p. Because why? We're doing a derivative on the x's. So that's how we get 2px. That p cannot be 0, okay, because it's not standing by itself. Now let's look at plus p squared. Plus p squared is standing by itself, so we're not going to put the 2 in front. So this p squared is practically a constant, so the p squared will become a 0. Does that make sense? Now we're going to have to change this fraction 1 over x squared. We're going to have to make it that looks like a normal exponent. So we're going to have to push the x squared up to the numerator. This will give us x to the minus 2. Take the minus 2, put it in front of the x, and subtract 1 from the exponent. Minus 2 minus 1 will give me minus 3. That minus 3 must be pushed down into the denominator, x to the positive 3. Okay, so try to leave it in a positive answer form if possible. But most times with tech maths in the exam, they still mark it when it has that minus 3 as the last step. Okay, but if you can just simplify it like that, then do it. If it's a very long question and it's going to take too much effort, then don't worry about it. Okay, because maybe when it's a simple one, they would want to give that mark for the simplified version, like you see from there to there. Okay, so from this step to this step, okay, they might give a mark there. Right, I hope all of that makes sense. Let's go to example 11. Now these are the more difficult examples, but all it's doing is putting more algebra into it. And so if you look at example 11 here, f prime x, if f of x is equal to that. So all you have to do is FOIL all of that out. Once FOILed out, you're going to get a trinomial. Don't forget, same thing, take the 2, place it in the front. 2 times 16 is 32, subtract 1 from the exponent, you get that. Here you have minus 24x, drop the x, you get minus 24. All constants become 0. Okay, and it's as simple like that.